Hello, good morning, students. So, today we are starting a very important topic of 12th physics, that is electromagnetic waves. It contains 3 marks, and this chapter is very important because we are dealing it with the electromagnetic waves that we are experiencing in our daily life. So, already we have studied that electric current produce a magnetic field. Also, a magnetic field changing with the time produce an electric field. And now the opposite question arises that can an electric field changes with the time produce a magnetic field? So answer to this question was given by James Maxwell. He argued that there was indeed a case of an electric field changing with the time producing a magnetic field. Maxwell again noticed that Ampere's circuit law, which is inconsistent and make non-unique predictions for the magnetic field in the situation where the electric current changes with the time. He showed that consistency required an additional source of the magnetic field, and that is called a displacement current. And this made the law of electricity and the magnetism symmetrical. So that means electricity and magnetism are complementary to each other. Maxwell give the four set of the equations, and they are known as Maxwell equations. So with the help of these equations, we are able to study whole of the electric field concept and the magnetic field concept. So that means these are the four base equations which comprises the electric field and the magnetic field. He found that electric and magnetic field depend on the time and the space propagate as the transverse waves, and, and that is called electromagnetic waves. He discovered that electromagnetic wave travel with the speed of light, and that give a very important conclusion that light is an electromagnetic wave. And this concept was experimentally demonstrated by Hertz. So his experiment brought a revolution in the communication which we are witnessing today. So next one is very important, that is Maxwell displacement current. We know that according to Ampere's circuit law, the line integral of the magnetic field B along any closed loop is proportional to the current I passing through the closed loop. So that is B dot dl is equal to mu naught I. Maxwell showed that the equation 1 is inconsistent, that means it is not applicable. To prove this, what he does that a parallel plate capacitor being charged by a battery that was connected in the circuit, and what he found that current I flow through the connecting wires, which of course changes with the time. Then the current produces a magnetic field around the capacitor, and what we found that current I flow through the area bounded by the loop of the circuit, and therefore the Ampere circuit law take the form line integral B dot dl is equal to mu naught I. So this gives rises to the some modification to the Ampere circuit law. Maxwell followed a symmetrical consideration that by Faraday's law of changing magnetic field produce an electric field, hence changing electric field must produce a magnetic field. So as the current are usually sources of the magnetic field and changing electric field must be associated with the current, so Maxwell called this current as a displacement current. So displacement current is the current that comes into the existence in addition to the conduction current whenever the electric field and hence the electric flux changes with the time. So next we are moving toward the definition of the electromagnetic waves. For a region where there are no charges and the conduction current, Faraday's Ampere's circuit law take the symmetrical form. that is line integral E dot dl is equal to minus d phi b upon dt, and b dot line integral b dot dl is equal to mu naught epsilon naught d phi e upon dt. It can be shown that time varying electric field produces the space varying magnetic field and vice versa. So electric and magnetic field are the sources to each other. Hence electromagnetic wave is a wave in which the electric and magnetic field are perpendicular to each other as well as perpendicular to the direction of the propagation. The properties of the electromagnetic waves. So let us see the envelope in which the electric field and magnetic fields are shown by the different colors, and the wave is moving in the x-axis direction. That means it is propagating along the x-axis direction, in which the electric and magnetic field are perpendicular to each other as well as perpendicular to the direction of propagation. So the first very important property is variation in both electric and magnetic field occur simultaneously, therefore they attain the maximum and minimum value at the same place and at the same time. So the direction of electric and magnetic field are mutually perpendicular to each other as well as perpendicular to the direction of the propagation of the wave. Electric field vector E and the magnetic field vector V are related by the relation C is equal to E naught upon V naught, where E naught and V naught are the amplitude of the respective field and C is the speed of light. And velocity of the electromagnetic wave in the free space is given by C is equal to 1 upon under root mu naught C naught, and it comes out to be 3 into 10 raised to power 8 meter per second. Velocity of the electromagnetic wave in a material medium is given by 1 upon under root mu epsilon naught, where mu and epsilon are the absolute permeability and absolute permittivity of the material medium. Next property of the electromagnetic wave, that means electromagnetic waves obey the principle of the superposition. Superposition principle means that the displacement can be added to give the resultant displacement. Electromagnetic waves carry energy as they propagate through the space, and this energy is divided equally between the electric and magnetic field. Next very important property is electromagnetic wave transfer energy as well as momentum to the object placed in their path. Next important property for the discussion of the optical effect of the electromagnetic wave, more significance is given to the electric field, and therefore electric field vector is called light vector. So that means optical effect is being observed due to the electric field vector. Electromagnetic waves do not require any medium to travel, that is very important, and an oscillating charge which has non-zero acceleration can produce the electromagnetic wave. So this is the first part of the electromagnetic wave, that what is the displacement current and how electromagnetic waves comes into existence and what are the main properties of electromagnetic wave. So thank you.